Okay, so now we're trying to get more intelligent with our turns, and we've also found a problem with our turn methods that we need to fix. So let's start with what we would like. Let's imagine we make a really great scan method that scans all of the available options and finds an option right here. Let's say it's 30 or 40 degrees turning to the right. So how do we get our robot to turn precisely 40 degrees right? Um, Now, we need to figure out the relationship between our variable, our turn variable, and a single degree. We have been using for our turn variable an encoder value. That 18 there are 18 spokes in a wheel, and so the encoder just counts how many spokes pass through a sensor. But it doesn't really work well. It never fails. So, I mean, it always fails. For example, it never stops is what I meant to say. Because if I say turn 9 encoder value, so that'll be count 9 spokes, and so it'll say 1/2 rotation, half a wheel rotation. This calls the API of the GoPiGo and says motor 1, motor 2, you both need to listen to this encoder value. Only count 9 spokes of the wheel and then stop. Then we'd say, okay, move, now start rotating. It should count 9 and then stop. It does not. It will keep going. The only reason why that does stop is because our timer waits for every wheel rotation, it'll wait 1.8 seconds. So if you're doing a little bit less, then it'll go a little bit faster. And then I'll tell it to stop. So what's actually controlling how accurate your turn is not really this number. This number affects the sleep, and that's what's really turning it. It's not the encoder value. It's the pause before we tell the robot to stop that's controlling it. That's unfortunate, and I wish I knew why this wasn't working well. But until we can figure out, and I get a sensible answer from the people that make the GoPiGo, until that happens, we need to revise how we're turning. So I'm experimenting with a new turn method. So when you run your student, you have always gotten this option number 2, and if you update your parent method, when you select this, it will call my new improved rotate method, where I will ask, okay, how would you like to modify the speed of your motors, because that does affect your turn. And let's say if you wanted, if you just said 1, then it would multiply 1 and by the left and right speed that you should have defined at the top of your code. And it'll just use that exact speed. But maybe you want to try 0.9 to get 90%. Let's see if you slow things down a little bit, if the turn will be a little bit smoother. So now I ask, how many seconds would you like to turn? This too is changed into a decimal. It's not an int, it's not a string, it's a float, which is a decimal. It's, if 0 is an integer, 0.0 is a float. So that's just quickly. But what this means is I can put 0.1, and that will give it a tenth of, it'll tell it to start turning, give it a tenth of a second, and then stop. And now you can start determining the relationship. So you need to find out 1/10 of a second. How many degrees will your robot turn right in 1/10 of a second? If you find that out, then we'll find a relationship of how many how seconds relates to the degrees. If we turn in this sort of fashion, we set up the timer, we say turn, we wait that time, and then tell it to immediately stop. So it won't be as accurate as we'd like, but we can get it pretty darn accurate, enough so that we can probably nail a 40-degree turn if we really wanted to. So once we find the relationship between seconds and degrees, then we will just multiply the number of seconds to get the number of degrees that we want to turn, 40 in this example, and then we'll be able to more accurately turn. So our next job is to experiment with your particular robot at what speed and at what time will turn to what degree. And that's our next big project.